Okay, hello everyone. From this video, I am going to start a new lecture series based upon some special integrals. Okay, basically in this video lecture, we are going to discuss two special integrals. One is your gamma function and beta function. Gamma function and beta function. Gamma function represented by this symbol and beta function is represented by this symbol. This gamma function is known as Euler's second integral. Also, it is known as Euler's second integral. Euler's second integral, and this beta function known as Euler's first integral. These two functions are represented by integrals. Okay, first we are going to discuss about gamma function, then we are going to discuss about beta function. No need to write the note, you just download. I will upload this note, this handwritten note I will upload. You just download and you can print that note and watch this video and prepare for your exam. Okay, so let's first we are going to discuss about gamma function, properties of gamma function, different representation of gamma function, and some numericals upon gamma function. Then we are going to move towards beta function. Okay, as per the definition of the gamma function, if we are going to define this gamma function, how it will be, first we have to write. मैं ज़्यादा नहीं लिखूंगा, very in short I will be write the note which will be useful for your exam. Okay, definition. The gamma function is defined by an integral such as gamma n is equal to 0 to infinity x to the power n minus 1 into e to the power minus x integration with respect to dx, and here n is always positive. Okay, n is greater than 0. You just remember this integral. This is your definition, simple definition of the gamma function or representation of gamma function by this simple integral. Okay, and this is also called as your what, Euler's second integral. Now we are going to discuss about other forms of gamma function. So I am going to put the heading that other form or other representation of gamma function. Other forms of gamma function. Just download this note in PDF format and prepare for your exam. One by one, different forms we are going to discuss. Gamma function also represented in this format. First one is your like this: 0 to infinity integration 0 to infinity e to the power minus ay. See here I have to write first this y term, it will be better. Y to the power n minus 1, y to the power n minus 1 into e to the power minus ay dy is equal to gamma n by a to the power n. First we are going to prove this one, this integral equal to this one. Then we are going to go for another forms of gamma function. Okay, so let's prove this one. So here you can see, if I'm going to compare this integral, here instead of x, y is there, n to the power minus x to the power n minus 1, here y to the power n minus 1. And here you can see, if I'm going to compare this one, exponent term e to the power minus ay, but here e to the power minus x is there. This integral is the integration with respect to x, and this is your integration with respect to y. That means here this exponent term only minus x is there, but here ay is there. So to write the integral equivalent to this one, what we have to do? We have to put ay equal to t. That implies dy equal to, sorry, a dy equal to dt. So here you can see y will be equal to t by a, right? And dy will be equal to dt by a. So instead of here y, we have to substitute t by a, and here instead of ay we have to substitute t, and dy will be dt by a. Now we are going to check, is the limit is going to change or not. Here you can see, when y equal to 0, lower limit is your 0, then t will be how much? Here we consider as ay equal to t. So if y equal to 0, t also will be 0. If I'm going to consider y will be infinite, then here you can see t also infinite, because here y will be infinite means t also infinite, right? Now the integral will be how? Then the above integral will be what? 0 to infinity. Instead of y, we have to substitute t by a to the power n minus 1 into e to the power minus t into dy. Instead of dy, we have to substitute dt by a, right? So this will be equal to, here you can see a is a constant, a to the power n minus 1, here a to the power 1. So a to the power n we can found that can be taken outside of this integration. 1 by a to the power n, integration of 0 to infinity t to the power n minus 1 into e to the power minus t into dt. So here t is a dummy symbol, can be replaced by any letter. If I am going to replace t as x, then this integral will be equal to this integral. Here t will be replaced by x, means x to the power n minus 1 e to the minus x dx, nothing but this integration. So finally what we can found? We found 1 by a to the power n, this integration is nothing but your gamma n. So we can write gamma n. This much we need to prove here, and we have been proved. Okay, so this is the another form of gamma function, uh, or gamma function, that may you can remember. First one, then we are going to move for second one. This is another form of gamma function, that is your gamma n equal to 0 to 1 integration 0 to 1 log 1 by y to the power n minus 1 dy. That also we are going to prove here. Here you can see. To prove this one, let us consider, let e to the power minus x equal to y. Okay, so that implies dy will be equal to minus e to the power minus x dx. And here you can see this one, if I'm going to consider e to the power minus x equal to y, that means, that implies minus x will be equal to log y. Okay, or I can write, or x equal to minus log y, or x will be equal to log y to the power minus 1, or log 1 by y, right? Okay, then so here instead of log 1 by y, we can substitute x, and instead of dy we can substitute minus e to the power minus x dx. Now we are going to check the limit. Okay, so here when y equal to 0, here I am going to put, if here if y equal to 0, then x equal to, when y equal to 0, then x equal to infinite, because log 0 equal to infinite. Then if I'm going to put y equal to 1, upper limit y equal to 1, then x equal to 0, because log 1 equal to 0. Now we are going to write this integral by substituting these values. Hence the upper integration or the above integration will be, hence the above integration or integral will be infinite to 0. Log 1 by y will be written as x to the power n minus 1 into dy is nothing but minus e to the minus x dx. Okay, this can be written as, here you can see minus, when this minus will be moved outside of this integration, the limit will be changed. So here 0 to infinity, x to the power n minus 1 into e to the minus x dx is nothing but your gamma n. Hence proved. Okay, now we are going to move for third representation of gamma function. Now third integral representation of gamma function is this one. Gamma n also can be represented as 1 by n 0 to infinity integration e to the power minus y to the power 1 by n dy. How it is? Let prove it. Okay. So to prove this one, let us consider x equal to y to the power 1 by n. Okay. So here that implies y will be equal to x to the power n. Okay. So that implies dy will be equal to n x to the power n minus 1 dx, right? So here instead of y to the power 1 by n, we can substitute x, and dy will be substituted by this much value. Now we are going to just check the limit. Here you can see y we have been considered as x to the power n. So if y will be the lower limit 0, that implies also x will be 0. If y will be infinite, then x also infinite. Now the above integral will be the above. You just download this note in the PDF format and prepare. The above integral will be what? 1 by n 0 to infinity. That means we are going to substitute these values. E to the power minus, instead of y to the power 1 by n, we are going to substitute x into, instead of dy, we are going to substitute n into x to the power n minus 1 dx. Okay, so here n and n got cancelled, and we found 0 to infinity x to the power n minus 1 into e to the power minus x dx, which is nothing but your gamma n. Hence proved. Okay, now we are going to move another representation of gamma function. Okay, this is the fourth one, representation of gamma function, that is your 1 by gamma n equal to n e to the power n mu. This is the product summation of k equal to 1 to infinity 1 plus n by k into e to the power n minus k. This is also called as Weierstrass form of gamma function. Okay, and here this nu is called as your Euler's constant, and it has a value that is your 0.5772. So this Weierstrass form of gamma function, this one can be proved with the help of infinite limit of Euler's form. That is the another form of Euler's Euler's representation of gamma function. This one, This Weierstrass form of gamma function can be proved by considering Euler's form of gamma function. Euler's form of gamma function, that is your gamma n will be equal to limit k tends to infinity 1 into 2 into 3 up to k whole divided by n into n plus 1 into n plus 2 up to n plus k. So this proof we are going to discuss in our next class. Thank you so much for watching this video. Thank you.